Alrighty, we're going to do two examples of factoring a trinomial. So both of these are going to be trinomials. I'm going to use what some people call the master product rule, or we can call it factor a trinomial by grouping. Sometimes they call it that as well. We're not going to do the trial and error. That is another method that you can do, but maybe we'll have another video for that if we need to. So when you do factor by grouping, the first step is to multiply the first and last numbers. 3 times -5 is -15. Now, you now want to find two numbers whose product is -15 and whose sum, so now I'm going to take this middle number right here, sum is +2. So, I could think of it, +5 times -3. 5 times -3 is -15, and 5 plus -3 is +2. Alright, what we do now is we keep the first and the last term the way it is, but we change the 2a to 5a minus 3a. So we're going to write 3a squared, which is the original first term, but instead of writing plus 2a, we break that up into 5a minus 3a. That's what we just found right here, 5 and -3. So plus 5a minus 3a. And then we keep the last term the way it is, -5. Alright, now we do what's called a factor by grouping. And when you do factor by grouping, usually you do that when there's 4 terms, which we have now. You cut right down the middle, and you factor out the greatest common factor of the first half. So we're just looking right now at the 3a squared plus 5a. The greatest common factor of that is just the a. And then if we factor that out, 3a squared divided by a is 3a, plus 5a divided by a, that's 3a plus 5. Okay, now our goal is to get a 3a plus 5 in the parentheses on the next one. But look, we have a -3a minus 5. So now the greatest common factor of the second half would just be a -1. So if we divide out each term, divide each term by -1, -3a divided by -1 is +3a. -5 divided by -1 is +5. Now see how we have the 3a plus 5 both times? It's exactly what we wanted. So now the 3a plus 5 is the greatest common factor, and we leave what's left, which is the a and the -1. So that goes here. A minus 1. We could do a quick check here. Let's check to make sure. 3a times a, 3a squared. 3a times -1, minus 3a. 5 times a, plus 5a. And then minus 5. We get 3a squared plus 2a minus 5. We get the original polynomial back. So this is, in fact, the correct answer. Okay, let's look at another one here. Now, the first thing you want to do here is you actually want to factor out the greatest common factor of 6. So if we divide everything by 6, we'll get a squared, and then we'll get minus 8a, and then we'll get 120 divided by 6 is 20. So minus 20. 6 times 20 is 120. Yep. Now you don't need to do the process that we did earlier, the factor by grouping. Back to that problem, the real reason that we do this factor by grouping is because the leading coefficient, this right here, this leading coefficient is not equal to 1. Alright, so if that's the case, then you either have to do trial and error, or this master product rule, or factor by grouping, which I showed you. Okay, so now, if we look at this leading coefficient is a positive 1, so we're okay. So now really all we're doing is we're going to try to find two numbers whose product is negative 20, the last term, and whose sum is negative 8, the coefficient of the middle term. And that's going to be negative 10 and 2. So negative 10 plus 2 is negative 8. And really that's just what we get. It becomes 6, don't forget to bring that down, a minus 10, and then a plus 2. So let's check the a minus 10, a plus 2, see what happens. This is just a check here. So bring the 6 down, so that means a times a is a squared, and then plus 2a, and then minus 10a, and then minus 20. That gives us 6 times a squared minus 8a minus 20. Looking good so far. Now if we multiply the 6 back in, we get 6a squared minus 48a minus 120, which is what we had originally. Therefore, this checks to be the correct answer. So in this problem, I had to factor out the greatest common factor first. You always do that. Always factor out the greatest common factor first, and then factor the remaining polynomial.